so my topic this year is building powerful clouds, right? Who am I, in case anyone didn't know? I'm Chief of Product at StorPool, a cloud architect, previously some packet processing stuff, and I'm kind of an algorithms and data structures person from a long time ago. What our company does is a fast and efficient software-defined storage system. We are quite active in the OpenNebula and KVM ecosystems, and not that active in other ecosystems. So most of our deployments, most of our customers use KVM. A smaller percentage use the Zen hypervisor or the VMware hypervisor or Hyper-V. And kind of a tiny percentage of our customers use our storage system for bare metal or dedicated server use cases. We have deep integrations in OpenNebula and OpenStack and ONUP and CloudStack, etc. One thing which is interesting for us is that in addition to being kind of an integration of OpenNebula, we are also an OpenNebula user. So we have a bunch of OpenNebula deployments ourselves, and we run them. So our experience in this stuff. Let's start with why would you want to build your own cloud instead of deploying your stuff in a public cloud? So it depends. Firstly, it depends on what is your use case, and depending on where you come from, you may have different reasons. So for a service provider, it's mostly about control and customization and price performance optimization and getting a better service quality for your users. So getting kind of an edge over your competition in terms of the services you offer or in terms of the quality of these services, right? For a web or mobile app, the default would obviously be, host that web application on a public cloud. Sometimes there are reasons why you don't want to do that. One is cost optimization. Another one is kind of automation and control. Compared to like a more traditional IT environment, in a cloud environment, you have the choice to automate things, right? And controlling your environment and customization is a big reason for a web or mobile app to run their application in their own cloud rather than in a public cloud, right? And thirdly, for a software developer company like ours, these are our reasons why we use OpenNebula, right? We have two things. One is compared to a traditional environment, in a cloud environment, you can give your developers self-provisioning capability. So, you give them a UI and they can provision VMs themselves, or give them an API and they start doing automation around that. And cost optimization and latency is also another aspect of this. So having the environment local where your developers are rather than somewhere far away, right? So there are different reasons depending on what you're trying to achieve. And there are also different types of requirements that we see. So some of our customers, they say, I want the best performance at reasonable cost. And it's almost like it doesn't matter what the cost is. I want the best performance available in the world because like my time is just too precious. I don't want to spend any time waiting for a machine to do things instead of going forward. In the service provider space, there is always this, the cost performance question. So good performance at like balancing performance and cost. And there are also use cases where the lowest cost per gigabyte is the requirement, kind of the lowest cost regardless of performance. So there are use cases like that. Our company is not particularly active in these use cases. We're more good in the other two cases, right? One thing to explain what we mean by a powerful cloud, one thing I want to explain is this kind of operations versus latency curve. And the reason I explain this in kind of almost any presentation I do is that it's very poorly understood, but it's very important. So any transaction processing system, be that a database, a load balancer, a storage system, anything that processes operations, has a characteristic that goes like this. At very low load, you get low latency. You increase the load and latency increases. So at higher load, you get slightly higher latency. And then there is a saturation point. So this knee here is called the saturation point. And once you go over that, you increase your demands on the system, and that just increases latency without increasing the operations that you receive from this system, right? Once you go over that knee, I say there is only pain there in that area of the curve. Most published benchmarks, so when you go to any vendor and they brag about how many operations per second their system can do, are up and to the right in that curve, and that's completely useless for someone that's going to use that system, because where you want to run your systems is down here in this range of the curve, not up there, right? You never want to run them in saturated mode. You want to run them in elastic mode, meaning when there is more demand, you get more delivered, not when there is more demand, you just get higher latency, right? So any interactive or transaction processing application, you always want to run your systems in the elastic part of the curve, meaning you can increase demand and you'll get more delivered by that system, which means running it in the kind of a few percent of its total performance, if its total throughput available. If you have a system that does 1 million operations per second, you run it at 10,000 or 100,000 operations per second. You don't run it at 1 million. If you run it at 1 million, that's probably cheaper, meaning it's cheaper per operation, but you're risking going over the saturation knee, right? And when you go over that knee, it's very painful. So what do we mean by powerful? Powerful is, so on this chart you have operations per second versus latency. And it compares virtual machines in different public clouds. One of them is private, actually. And how to read that. So the way to read that is if my application does, say, something modest, like 2,000 transactions per second, if I put that application on a StorPool best current practice environment, so if you put that application on an environment that is deployed exactly per our recommendations, you will get these transactions delivered at 1 millisecond or slightly over 1 millisecond per transaction, right? And if you try to put that on DigitalOcean or OVH or DreamHost, it wouldn't even be able to deliver the 2,000 transactions at any latency, right? So even though if you look at the specifications of these services, they look very similar. So it's a VM with this much memory and this much CPU, and it's a storage device with this many IOPS provisioned on it, right? The performance, the application performance you get out of this is extremely different. There is there are nothing alike, right? Other things about this chart. The application we're running here is called pgbench. It's kind of representative of a transactional workload. We've also tried doing the same with sysbench with MySQL, so it's not specific to PostgreSQL, right? Any transactional database would have a fairly similar characteristic. And every dot in this chart represents a particular load level. So meaning for that many transactions per second, what would be the latency per transaction, right? So back to the question. When we say a powerful cloud is a cloud that gives you application performance up and to the left on this chart. Meaning you can get more transactions per second at lower latency. That's the logic there. Kind of slightly weird thing about this is this is very hard to judge upfront. So if you just look at the spec sheet of a server or the spec sheet of something that someone is promising you, you can't tell how this chart would look like. You need to go and actually run the benchmark, right? Unfortunately, that's the state of our industry. There are some certain things which you can only measure, you can't predict, right? All right, so how we would build and how we've built clouds like this. We do it with StorPool and OpenNebula and KVM. KVM, there are many reasons why exactly this combination of things. Well, StorPool is a fast, low latency, extremely efficient storage system. KVM is an open source hypervisor with a very good, very wide user base. There are a lot of users of KVM, and there are also a lot of developers of KVM. And it is arguably the best hypervisor available at the moment at any cost, right? So if you go to, say, VMware or Hyper-V, you wouldn't get the same level of performance you can get with KVM. It's not the easiest, but it's arguably the best, right? And OpenNebula in the middle, obviously, takes care of orchestration. And if you look at alternatives to OpenNebula, mostly they're either not as capable, so that they can't do the things we want to do, or alternatively, they're extremely complex. So if you look at something like CloudStack or OpenStack, it's just another level of complexity. Well, OpenNebula, how many of you are using OpenNebula at the moment? All right, about half of the people. All right, some are trying. So to describe it in very simple terms, OpenNebula looks like, in terms of architecture, it looks like a two-tier web application. You have OpenNebula on top of a database, and then there is an API on top of that, and that's that. There is no kind of multiple moving parts running on different machines, and how do I upgrade that, and all these complex questions, right? So it's kind of single controller, one OpenNebula controller talks to all the servers in that zone. Compared to some other architectures, it's extremely simple. So another reason to choose OpenNebula is the OpenNebula ecosystem, right? So OpenNebula is an open source project. It's it's an open source project, but as you may know, there are two types of open source projects. There are kind of foundation open source projects with many parties involved, and kind of decision by committee process, which doesn't get a lot of results. OpenNebula is the single vendor open source model, meaning there is one company that takes care of developing and pushing that project forward, which is OpenNebula Systems. And that gives it a lot more kind of focus in a particular direction, which means when OpenNebula Systems decides that they want to move that project in a particular direction, it's kind of the whole project moves. There is kind of no committee that they need to go in front of, right? There are a number of companies around that kind of working in the OpenNebula ecosystem, providing solutions, including OpenNebula, or providing plugins or integrations or things like that. StorPool is one of these companies, right? So we have an integration with OpenNebula. And there are some others which I've mentioned here. They're not particularly active in Bulgaria, right? But they do exist out there in the world. So NodeWeaver mostly active in Italy, and Sharks mostly active in Russia, right? Sharks DC. In Bulgaria, so I've tried to kind of compile a list of OpenNebula users in Bulgaria, just to show you guys that whether you're using OpenNebula or not, you need to know that there is a fairly large user community for OpenNebula in Bulgaria, right? So a lot of people are using it. We haven't done a very good job of kind of communicating with each other and helping each other solve our issues. But off the top of my head, just writing down the list, it looks like, Imperia Online, InnoLogica, also kind of their main products, InnoReader, there is AData Pro. We use OpenNebula. You have Extreme Broadband, Extreme Peering. And in the service provider space, we have NS1 and Delta. All of these are using OpenNebula in one way or another. I think something we need to do in the Bulgarian OpenNebula community is kind of make these meetings more regular and try and help each other with any issues we have with OpenNebula, right? Back to the topic. So one reason to choose OpenNebula is the ecosystem, right? There are many users and an active community. So how do these, when you've decided you want to build a private cloud, how do you do it? You could go hyper-converged or standalone. So this is kind of a architectural question, you know. What servers should I use? How do I connect them? Et cetera, et cetera. And depending on your requirements, hyper-converged might be the better choice, or hypervisors and a separate storage system might be the better choice. Kind of weirdly, between these, it's about 50-50 in terms of people who deployed hyper-converged or people who deployed like a standalone storage system. Why do hyper-convergence? One reason is efficiency. So especially if you have a storage system that can only take a few CPU cores, you don't halve the number of servers you have, but you may reduce the kind of rack space and number of servers and cost by tens of percent, maybe 20-30%, right? How would a server like that look like? Something like this. I guess not very interesting for this audience. How do you select components? So one kind of common mistake I see is that when you're deploying a large environment, so if you're deploying an environment with thousands of virtual machines, what you want to optimize it for is cost of delivered resource, right? So you don't optimize for how much does one server cost, right? You optimize for how much would it cost me to host 1,000 virtual machines. And it gets, it's not very complex, it's just large spreadsheets, and the results of these spreadsheets are sometimes surprising because it's not kind of, we as humans, we don't have a natural ability to calculate these things. So the results from the spreadsheets are unusual sometimes. So one unusual result is that the lowest cost per core you get from a CPU which costs $3,000, right? So if you look at kind of total cost per core when you calculate the data center space and the power and et cetera, et cetera, et cetera, ends up with a CPU which is $3,000. This is a public spreadsheet. Anyone just ask me and I'll give you access to that. So, unusual outcome of this exercise of optimization is component level, the cost of the particular component really doesn't, it's not directly related to the cost of the delivered service. You end up with expensive, extremely expensive CPUs being cheaper than a lot cheaper components, right? One example for a customer that did something like this. So they're a private cloud for production public-facing application, and their application is high-end VDI. So they give kind of VMs to gamers and CAD companies. In their design, they've decided to do this with independent racks, meaning whatever happens inside one of their racks, it wouldn't affect the service provided by a separate rack. Each rack contains 28 hypervisors with 4 times as many GPUs, right? So a very large number of GPUs per rack and a fairly high power density also. So like above 10 kilowatts per rack, definitely. And yeah, so this is kind of their requirement is a very strong case for software-defined technologies, meaning everything they use is software that runs on standard servers that runs in their standard operating system, Linux. It's a very strong case for hyper-convergence, because if they didn't do hyper-convergence, they would get a lot lower density per rack, and it's a very important kind of business parameter for them. So when should you do hyper-convergence? If you're doing greenfield deployment, so you don't have like a legacy to bring along legacy servers. if you're using the KVM virtualization, and if you're doing like small availability zones or pods design architecture, and when you should do a standalone storage system, if you're doing a retrofit. So for example, I have 200 servers and I want to provide additional storage services to these 200 servers, then a standalone storage system might be the better choice. If you're using Xen or VMware or Hyper-V, if you have requirements for independence of infrastructure, so for example, I don't want an issue in my KVM environment to affect my VMware environment, and the way you do that is you put them on separate physical servers, right? Or you may have a requirement for administrative boundary. That means, for example, in the service provider space, if you're providing dedicated servers to your customers, you don't want part of your infrastructure to run on these dedicated servers, which you've given to your customers. And in that case, you separate them by having your infrastructure run on one set of servers and your customers using a separate set of servers. So how does StorPool work with OpenNebula? Well, OpenNebula with the KVM hypervisor, we install the StorPool driver in the host operating system of each hypervisor. You get block devices in the StorPool, and these are given to QEMU like raw disk images. And all data management, like creating volumes, deleting volumes, cloning, resizing, snapshot, etc., is deeply integrated in OpenNebula. Meaning, if you have a template in OpenNebula and you create a virtual machine of that, underneath, OpenNebula knows how to tell StorPool to create a space-efficient copy and write clone of that base image. So you end up with a base image, say a CentOS 7 base image, and then a virtual machine which doesn't take any space initially, right? It's just like a copy and write layer on top of the base image. So StorPool implements like a data store driver, and the code is over there, and there is some documentation around that as well. Yeah, so if you're using OpenNebula with VMware, then the way we connect to VMware is over iSCSI, and which we have our own iSCSI scale-out target with multipath, and VMware lays a VMFS file system on top of that. So it's a very different way of integration in the OpenNebula VMware case and in the OpenNebula KVM case. And kind of finally, to give you to set some expectations. So mostly, kind of to rule out any misunderstanding, a StorPool KVM OpenNebula system can deliver performance metrics such as these. So these are 100 microseconds to commit a write operation inside a virtual machine, right? So I think an important point here is it's not IOPS for the sake of IOPS, right? It's we want these to deliver extreme performance for the sake of good application performance, right? So it's all in service of the application. Getting an environment in which, with a performance like this, enables someone to take any part of the application which traditionally could only run on a dedicated server and move that into a virtual machine and gain from, say, the automation or gain from the higher availability of a virtual machine compared to a physical server. So this was kind of just to set some performance expectations. A StorPool in OpenNebula system can deliver these kinds of performance metrics, which are, you know, extreme. There is, I'm quite certain there is no application that needs 13 million IOPS, right? I don't know what that application is, but the point is, you wouldn't run this system at 13 million IOPS, right? You would run it at a tenth or 1% of its full capacity, and you would get better application performance by doing that, right? Sorry. That was that. Well, thank you.